How's it going, guys? Welcome to Rojo's Reasoning, episode 1. So, today we'll be working through problem number 25 of chapter 2. And this one deals with the Concorde flying from North America to Europe. So, we will start with kind of what we know. We know that the flight was 8,000 kilometers. I went ahead and just switched that to meters because the velocity is in meters per second. So in meters, that's 8 times 10 to the 6th meters. And as I just mentioned, its velocity is 375 meters per second. So the equation that we want is T prime is equal to gamma T naught, where T prime is the time in the moving frame, and T naught is the time in the proper frame, or the non-moving frame. Here, gamma is equal to 1 over the square root of 1 minus beta squared, and beta here is just the velocity over the speed of light. So let's kind of start working through it. First, we want to find T naught, so the time in the non-moving frame. And to solve for T naught, all you had to do was take the distance, which was 8 times 10 to the 6th, all over your velocity, which was 375. And when you do that math, you come out with 2.133 times 10 to the 4th seconds. So here we have our T naught in this equation. So I'll write that up on top of the board here, just so we have that. So T naught is equal to 2.133 times 10 to the 4th seconds. So we have that out of the way. We can erase this guy in the middle, just so we can have some room there. Next up, we will solve gamma. So when you plug in your VC for the betas, you end up getting 1 over the square root of 1 minus V over C quantity squared, which equals 1 over the square root of 1 minus 375 over 3 times 10 to the 8th. Now, when you do this, gamma actually comes out to equal 1, and that doesn't help us at all, because that means that T prime is equal to T naught, and that's not true in this case. So, what we have to do here is plug in our expansion, and our expansion comes out to gamma equaling 1 plus beta squared, and that's over 2. And so again, beta is just V over C. So this is equal to 1 plus 375 over 3 times 10 to the 8th. And that is over 2. And when you work out that guy, you end up getting 1 plus 7.8125 times 10 to the minus 13. Hopefully you can still see that, yeah. So you get 1 plus 7.1825 times 10 to the negative 13. So that value is now gamma. And I forgot why. I know that we had used one of these before, but I forgot why. But when plugging it into the final equation, you don't need to worry about 1. So up top here, I'll have gamma as equaling 7.8125 times 10 to the minus 13. And this has no units just because all this stuff ends up canceling out. So we're just left with a unitless number there. So now that I have gamma and I have my T naught, I can now start working towards finding my T prime. So here we have the equation again. We have T prime, which is equal to gamma times T naught. So we have T naught up top here. We have gamma. So all we need is our T prime. So T prime is equal to 7.8125 times 10 to the minus 13. And we're multiplying that by 2.133 times 10 to the 4th. And when you do all that lovely math, you end up getting 17 nanoseconds. And so I think in your calculator, wherever you do it, you'll get up like 0.00000017. But if you remember, nanoseconds is 1 second times 10 to the ninth. So I just saved my ink here and I did it all in nanoseconds. So this is the answer for number 25 in chapter 2. Thank you for listening to Rojo's Reasoning, and we'll see you on the next one. Bye, guys.